I was just giving a couple of minutes there for everything to get fired up. So welcome back to Create Your Own Flute in Fusion 360. So we're looking here today at making the middle joint, as it's called. So this is what we're going to actually do today. We're going to do the timber section of the middle joint. But before we do that, we just have a quick look at the drawings to go through some of the peculiarities of this particular section. The key difficulties, that one of which we've met before and one of which we haven't, is that this is not a cylinder, either on the inside, which we haven't met, or on the outside, which we have met on the barrel. So it goes from a width that matches the barrel to a width that will match the tailpiece on the outside, and an internal taper of 1/60, which gives you a target angle of just under 1 degree. So I have included in the drawing as well the very small changes in the sockets at each end, where they marry, in this case to the barrel, and in that case to the final piece of the flute. And there are 3 sections to this. There is a 22mm diameter 4mm piece that drops then to 21.5, which is set to house a 1mm thick piece of cork for compression fitting, and then that drops to 21mm piece for 4mm, which will hold a metal ring to provide strength to the timber. That will be 1mm, so that will lift the 21 to 22 to match this section here, and it will provide a little valley to house the cork and prevent it slipping down or slipping up. And you have a similar arrangement at the narrow end. Okay, this piece is going to be built in a single run. We will be coming back later on to show you how to do it in 2 sections, with an upper middle joint and a lower middle joint, so you have alternatives here. This will put strain on any reamer that's going to actually ream out this length. The reamed length is the full 334, which is 1/3 of a meter. That's long, as opposed to doing it in 2 sections. But that's the way we're doing it, because this is an exercise in Fusion 360 rather than an exercise specifically in designing your flute. Okay, so we will now move over to the model, and I have done it all here. So here's the history. So I'm going to go back to the start and make sure everything is visible. Sketches, constructions. Yeah, I'll go back to the start, and I'll walk you step by step through what we're actually going to do before we commence doing it. So first thing we do is we create a construction plane. On that construction plane, we create the first sketch, and that's the main shoulder and the main plane. If I was to look at it, that's 28.5mm from the YZ axis. We then create the narrower end of the main body, and we will join those 2 up with a loft. That will give us the taper on the outside. Then start growing the shoulders close to the YZ axis. So draw a circle, extruded 4mm, draw a circle, extruded 20.4mm, draw a circle, extruded 4mm, and then come up to the other end and do more or less exactly the same 4mm extrusion, a 12mm extrusion, and then another 4mm extrusion. And we've one last thing to do. That's the solid piece of timber created now. And the last one we do is we're actually going to bore out the inner tapered bore using the extrude tool with an angle. So I'll just bring up that extrude tool with an angle so that you can have a look at it, and you can see the tapered extrusion operation cut with a taper angle of just less than ½ a degree. That taper angle that Fusion is looking for is known as the cone semi-angle of the taper. So it would be the angle between the side of the taper and the x-axis. So its tan would be 1 in 120, while the taper technically in wood turning terms is 1 in 60. Okay, so that's good. I'll just pause now and then I'll delete everything and we'll start again. Okay, so here we go. Once again, the written instructions for this session are available in the description for the video. And there's a little bit of maths in there for you as well on the calculation of the cone semi-angle from a taper of 1 in 60, and the drawing for the containing all the parameters is on the last page of the 3-page document in the instructions. So get a copy of that in front of you. It'll help you a lot during the course of this session. So we want to create a file, new design, and save it. I've saved my version as the middle joint for the class, and as you can see, I'm on model version 7, so I've been working on this a fair few times. So make sure you save the file into the same folder as you have Sorry, I had to go away there for a few seconds. Fusion threw a hissy fit at me and I had to close it down and bring it back up. So we're going to start with activating the middle joint class model. And we do assemble, new component, and I'm calling this middle joint timber. And everything is good there. Check that it's selected and active. And the first thing we're going to do is select the YZ plane, and we will construct an offset plane from that at a distance of 28.5 millimeters. Then create a sketch. That plane is going to be a circle. Make sure you're at the origin, and we want that circle to be 28.5. Finish sketch. Now, I've said in the instructions that you can rename that construction plane. The way you do that is double click on it. Sometimes it can be a little bit problematic to pick up, and I'm going to call that the main shoulder. And it'll take spaces, so you're good there. So we're going to select that plane, and we're going to create another offset plane for that, which is going to be 286 millimeters along. Now we'll select that plane, and we'll create a sketch on that plane, and that's going to be another circle. Go for the origin, and we want this one to be a circle of 24 mil. We'll finish the sketch. Now we'll create a loft. And that's the main part of the external body build. Now we can rotate the view to look at the main shoulder, or we can just simply go to that plane there because we're going to create a sketch there. But we go around and we'll select the face there, and we'll create a sketch, and it's going to be a circle. Put it on the center, and this circle is going to be 22 mil. Now I'm going to do a little keyboard trick here. I'm going to hit the letter E while the sketch is not finished. And that goes into straight into extrude mode. The only problem is that it can be a little bit hard to see what the direction of the extrusion is. So we'll select the face and go 4 mil towards the YZ plane. Then we'll select this one. We do a circle on this, hit the letter C, and this is 21.5. We'll try E again, extrude. Now I have 2 profiles selected, only want one. And we want that to be 20.5 of an extrusion. Sorry about the delay there. Pick this guy, draw a circle again on it, center, and we want this one to be 21. Finish the sketch this time. Select the circle and extrude, and we want it to go for 4. Now it's a good idea to have a good frontal look at this and make sure that everything looks to be in order. 4, yes, 20.5 and another 4. So we're finished at that end. We can go to the other end. Again, we can start either on the construction plane or just select that face, and we'll draw another circle here. And we want that circle to be 17. So here we'll be looking at circles of 17, 16.5 and 16. Finish sketch, and we'll extrude that 4 mil. I want to pick the tool first this time, and then pick the face. Hit C for circle. Pick the center, and we said we wanted 16.5. We'll finish sketch. We'll extrude that. I think that was an extrusion for 12, just bringing up the notes. For 12, yeah. This face, draw a circle. Like this is to be 16. Yes, we finish sketch. We'll extrude it for 4. we'll fit it all on. Get all that stuff out of the way. We're looking good here, 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 here. At this stage, it's a good idea to create drawing, new drawing, and bring this in and have a look at it and make sure your parameters are all correct. Okay, now we'll see that we have worked our way nicely back to the YZ plane. You can see it popping up there. I'll just turn it around there. So all the dimensions look to be correct here. So I'll just bring that back up. Well, sorry, I want to make sure the timber is active. I'll just shrink that. Now, it gets fun. We want to create a circle here. And this circle is 19. And that matches with the internal bore of the socket in the barrel. We'll finish the sketch. Now we'll select the sketch and we're going to, we'll select that face and we will extrude. Now there's two ways we're doing this. You could put another sketch down at the other end of the barrel of the of the flute section, and you could loft a cut from the wider to the narrower. But what I'm going to do is I'm going to use the ability of the extrude to actually cut at an angle. So I'll just fit everything, take that extrude up there, and we're going to cut and we'll pick distance all the way. And you can see it has actually cut out some of the timber down at the other end, but it has gone the right distance. Now, so we put in a degree, we put in 0.5, and 0.5 has made the taper wider. So we put in minus 0.5. And you can see how it brings in the taper nicely. But the actual angle we want is not 0.5. It's close to it. It's 0.447745. 3777. There's accuracy for you. Now the calculation for that is included in the instructions in the description. So we'll take a look at the front and we'll just fit it. Actually, we'll hide that. We'll fit now. So that fits nicely. And now we modify physical material. See, I have water from the previous get-go. And we'll close and you can see we have a nice taper. Now I'm going to create a drawing out of this so that I can check to see, did I get the circle? By using the taper, did I get the correct circular opening down at that end? So we will save this. We file new drawing from design. We'll go to ISO. Typically I use A4 for this. Yeah. Where did you go there? Just getting rid of this. And we'll see, I think it fits at 4 to 5. That's nice. I wanted to show hidden edges. We'll close that. So we will look at dimensions. You would have seen this before. So brought up the angle between the two. escape, get out of the tool, get the little grey dot, move the number up there, get out of the tool, double click on the diamond dot 0.95 and go over to the angular precision and see what precision we have. Close. We zoom in here then and we'll go for dimensions again, and we're looking for the distance between that intersection and that intersection, and we get 13.43. Get out of the tool by hitting escape, double click on this, and what precision does it offer us? Well, that's as good because it only gives 3 digits, but when you're turning wood or timber or a flute, that is a greater accuracy than you'll actually be able to achieve at 1,000th of a millimeter. But what it does prove is it gives us the right dimension at that opening, having put in the taper. And it's the way I favour for building internal tapers in drawing out any instrument, whether it's cylinder pipes or any other instrument. Okay, I think that's us done. Just check the notes. Yeah, that's us good. So when we come back, we'll probably do it in a single sitting. We'll put in the cork there, and we'll put in the metal ring there and there. And as these metal rings are structural, we'll probably use something like aluminium, and we'll put no ornamentation on them. Okay, so that's me good, and we'll talk to you again soon. Thank you.